Hey everyone, welcome to your next AAF video lesson. So I'm going to do this a little bit differently this time, and instead of there being a PowerPoint attached or linked, I'm sorry, it's actually a Pear deck. So what I'm going to hope that you all do, and obviously I'm not at home to make sure that you do it, but what I'm going to encourage you to do and hope that you do is that you click that Pear deck link. It's not actually, we're not checking all of your work. It is really neat for us to be able to look through and see if there are any common things that are happening. But I'm almost gonna act as if I'm doing this live in class. So I'm gonna go through different things and I'm gonna tell you to maybe pause the video and type in your answer. Obviously, I can't project student answers on the board because I don't have them. But you'll be able to then play the video and see if you got your answer right or what you might need to work on or are there edits you need to make. Um, After this lesson, a little bit later, so I will end the video. I'm sorry, I will end the Pear deck and I'll send you a takeaway. So you'll get all of this stuff in your notes as well. So I encourage you to do that if you would like. So what we're going to start with here is I want you to take a moment, and before we even really dive into this lesson, write out everything you know about inverses, right? That might be a familiar word to you. Maybe pause the video and in there, just go ahead and list them out so you know what your background knowledge is. So now that you've hopefully had an opportunity to do that, let's see what we can build on. Let's see what you already knew and what you might learn by the end of this. So, our agenda. You did the warm-up, I think. We're going to go over what I'm going to refer to as the 5 fun facts of inverses. These are very fun facts. We'll do some practice, and then this really isn't your homework, but like what I would encourage you to complete after this is to finish this Pear deck practice. So the things that maybe I'm not going through in the video, maybe you're going to continue to work on and progress through this. All right, fun fact number 1. So, inverses are reflections of one another over the line y equals x. So in this image, f of x and g of x are inverses. And I'm asking you to sketch the graph of the line y equals x, which is the line of reflection. So pause the video, and on your own, on Pear deck, go ahead and try that. Now that you've hopefully had an opportunity to do that, I'm going to go ahead and actually draw this line in. So the line y equals x is the diagonal line that has a slope of 1 and a y-intercept of 0, right? So I would have like a point here, a point at, this is not, the scaling is very interesting, isn't it? -2, -2, -4, right? It's literally where y and x are equal. So it's this diagonal line. I'm going to draw it as a dotted line as best I possibly can. Not my prettiest line, but it's actually not too bad. That is the line y equals x. So you can see that if I were to fold the paper, if I took this paper, pretend this little blue thing is a paper, and I folded it, this red line, so like this part up here, would lay right on top of this navy blue line, right? So that is a reflection over the line y equals x. That is fun fact number 1 when we're looking at inverses graphically. So take a close look at this. You might need to come back in a moment. My next question for you is, did you notice what happened with the coordinate points? Pause the video and type in your answer. If you need to go back a slide, go back a slide. What did happen? Right? Let's take a close look at this point and this point. Or even better, not even better, just in addition, this point and this point. 3, 11 became 11, 3. -7, -3 became -3, -7. So my x and y coordinate switched, right? Or maybe I want to say my variables. Maybe that's a better way to say that. My variables switched. I started off with xy, and it became yx. Ooh, does this look like something you did, I don't know, a year ago? Maybe? Right? So it is something that you did a year ago, right? So our fun fact number 2, remember fun fact number 1 was the reflection over the line y equals x. Fun fact number 2 is that you switch your x and y coordinates. Inverses have variables that are switched. This was called coordinate notation. You did it in geometry probably a year ago, right? So if I asked you to determine the inverse of this set of points, this discrete set of points, take a moment and pause the video and try it. Hopefully what you said was the set of points that is 3, 2, -1, 4, 12, 7, 14, 5. Oh, look at that, 9, 9. That's on the line of reflection, right? That's why it didn't change. And then -17, 8. Amazing. Oops. Oh, I thought it didn't disappear. So fun fact number 3, the inverse of a function will also be a function if the original function is 1 to 1, right? So we've talked about how you can determine if a given equation or a given graph is a function, right? And even a graph, right? Like if you're dealing with a parabola, a quadratic, it passes the vertical line test. But be careful here. Is its inverse a function? This is actually not 1 to 1. Right? So 1 to 1 means every x has one y and every y has one x, right? It goes both ways. It's not just every x has a one y. That's what makes it a function. What makes it a 1 to 1 function is if it works both ways. If I pick the y value 4, I get the x value 2 and -2. Therefore, it's not 1 to 1. So the inverse of a quadratic would actually not be a function. Crazy, right? So a function is 1 to 1 if there is a unique domain value for every range value, right? So that's why this quadratic didn't work. If I gave you an output of 4, a y value of 4, a range value of 4, it has 2 domain values. It has 2 and -2 that would result in that. Therefore, it's not 1 to 1. So the things that you want to think about are you starting with a function? Do you have a 1 to 1 function? If your answer is yes to both of these, your inverse will be a function. If your answer is no to either one of these, your answer is no, right? So it's like, I'm not going to be dealing with the inverse won't be a function. So I just did this one, right? So is it a function? Is it 1 to 1? And then inverse a function? Take a moment and write out your answer for this. Remember to explain. I hope we did explain. So is this a function? Yes, right? It passes the vertical line test. I'm going to explain in words. Hopefully you explained in typing, right? So yes, this is a function because it passes the vertical line test. Is this 1 to 1? Nope. It's not 1 to 1, right? If I picked this value right here, I have 2 possible x values that would result in that y value. Therefore, no, the inverse is not a function. You can even go as far as to think about not only does it pass the vertical line test, but does it pass something that we're going to call the horizontal line test? I'm blanking. I don't think we've talked about that one yet. Right? If I were to draw a bunch of horizontal lines, oh shoot, look at that. It touches it in two places. Therefore, the inverse is not a function. So that was fun fact 3. So we've done reflect over the line y equals x, the variables switch, and then if it's 1-to-1, the inverse is a function. If a function is 1-to-1, the inverse is a function. So this next one is more based on notation. So there's not really something you're looking for. It's just really important for us to think about notation and be precise. So if the original function is a 1-to-1 function, right? So just like instead of just always sticking a y on there, function notation is instead of y, we're going to shift it to being f of x. Right? So if we're saying f of x, and if f of x is 1-to-1, meaning if its inverse is a function, then we can use this, which is inverse notation, right? So if the inverse is a function, use this notation, right? So it's not necessarily saying, you're not really looking for anything. It's basically like if we've gotten to this point, I want to see this notation. So our last fun fact, which I'm going to start at right now, but you're really going to get the brunt of this one in class, is when you compose inverses, you get x. And the idea is, like, let's say if you do something and then you undo it, right? That's the idea of an inverse. It's like if you start with, I'm totally blanking on something now. Let's say you start with a present. You bought me a present and you wrap the present. That's f of x. Wrap present. And then, well, the opposite of wrapping is unwrapping. And then you unwrap the present. You just end up with the present, right? Which is what you started with, the present. So if you do something to it and then you undo it, you're going to end up with what you started with. So therefore, if they are truly inverses, when you compose them, you'll get x. So if I do f of, and this is one notation, I could also write it as f of f inverse of x. I'm going to get x. And it's going to go the other way too. So I do want to be mindful to do both. If I do f inverse of f of x, I'm also going to get x. But if you plug one into the other, you're ultimately undoing that. So that is how we can use some of the background knowledge, what we've been working on, right? Where we can use function composition in order to verify inverses or check if things are inverted, right? So this is a way of doing it. Amazing. So those are our 5 fun facts. We're really not going to get too much into composition, as I just said, until we see you in class during our next live session. Right now, I just want you to think about it and how that kind of all ties in together. And that's really where our focus will be when we come back together soon. So in these next few slides, there's going to be some practice. And what I would really like, especially if you haven't paused the video at all, is to use this now as a resource to practice. So no, there's no per se answer key to this. But take some time to like work through them and work through the end of this. So like this is slide, what are we on? 11. You have some more pages of practice here where you can kind of get into it and see what you really need to work on. And then it also gives your teachers an idea of where are some issues that we can focus in on when we come back together in class. So graphing inverse, filling in a table, explaining why they're inverses or why they're not, right? So take some time and work through these. And then when you get to the end of this, right, so a table and graph, I want to know exactly where you are with this. And so you can share this information and put this on here to provide us some information about how we can best support you as we move forward with this topic and prepare for our next live class session. So in this lesson, what you should have learned were the 5 fun facts about inverses and had an introduction to inverses. And then know that when we come back together, we'll be focusing on composition to verify inverses. And yes, make sure that you are beginning to work on your take-home quiz, which is due at the end of this week, Friday night. So thank you everyone for watching, and I will see you all next time.